In this part, now we're going to talk about leading degree and leading coefficient. Leading degree is the highest exponent within the expression. And then leading coefficient means the number in the term that has the highest exponent, or LD, that has the leading degree in the expression. So say I wrote an example. So negative 2x to the third plus 5x squared minus 7x to the ninth plus 8x to the sixth minus 4x to the seventh. So now you might have a question where these terms, let me underline them. Alright, so we have 5 terms. You might have a question where they're not in order. Now, if they are in order, then you can easily see. Now, I want to talk about this one first. So you might have some where they're not in order. If they are not in order, then you always just look for the highest exponent. In this case, it's this one right here, 9. So it has the highest exponent because if you look, 3, 2, 9, 6, and 7, of all the exponents that you have there, 9 is the highest. So if 9 is the highest, then my LD, which you can just write this on your test or in your work, LD is 9. So if LD is your 9, if your leading degree is 9, then your leading coefficient, or LC, is the number that's in front of the variable that has the highest exponent. So let me repeat. Your leading coefficient is the number that's in front of the variable with the highest exponent. So in this case, it's negative 7. Which is pretty simple as what I just did here. But in the past, I had students that mix up to 2, or that they would assume that the first exponent is a leading degree because they confuse that leading degree is the one that comes first, which is not true. I specified that it has the highest exponent within the expression. So in this expression, it's not in order. Typically it is, but in the event if it's not, and I want you to be familiar on how to identify the leading degree, the one with the highest exponent, just look at the exponent individually. Identify which one is the highest, which in this case it is the 9. So your leading degree is 9. And then your leading coefficient is the number that's in front of the variable with the highest degree. Now, in the past, I had students that they would just write 5 for the leading degree, meaning that they're 5 exponent, when again, that's not the case. That's not the definition that I given. And sometimes they would add up the exponents when they didn't have to. So for leading degree is you find a term that has the highest exponent, and then leading coefficient is the number in front of the variable that has the highest exponent. So we're going to do some more examples on finding leading degree and leading coefficient. In this example, we have an expression that has 6x to the fifth minus 4x to the third plus 7x squared plus 11x to the eighth minus 17. Now, typically, and you may be asked to put the terms in order starting with the highest. So, if you look at the exponents that I am underlining, you want to start with the highest, and it goes from in descending order from highest to lowest. So 11x to the eighth will come first, and then the one with the second highest, which is x to the fifth. So I'm going to write plus 6x to the fifth, and then minus 4x to the third plus 7x squared, and then minus 17 the constant number always come last. So make sure you be able to put it in order based on the exponents. And in this example, you actually have 5 terms. 1, 2, 3, 4, 5. So in this example, I was able to put the terms in order from starting with the largest or highest to lowest or least. Now from here, if you do put it in order, then the one that has the highest exponent is this one, my 8th, or the exponent that is 8. That's going to be your leading degree. So your LD, or leading degree, will be 8. Your leading coefficient will be the number in front of the variable that has the highest exponent, which is 11. So that's all you have to do. And then I would just simply box this up. So again, that's all you have to do. If you were asked to put it in order, that's how you would put it in order, starting with the greatest or highest exponent, and then going from greatest to highest to least or lowest exponent. So in descending order, 8, 5, 3, 2. That's how you're going to put it in order. In this example, we have an expression that has 2x to the 5th minus 19x to the 7th plus 6x to the 3rd minus 12x to the 10th minus 4x to the 1 power plus 9x to the 4th. So if you were asked to put it in order, you're going to start with the highest exponent, in this case the 10. So negative 12x to the 10th, and then what comes next is the 7th, so minus 19x to the 7th, and then the 5th, so plus 2x to the 5th, and then the 4th, so plus 9x to the 4th, and then the 3rd, so plus 6x to the 3rd, and then let's see, I would say the x, so minus 4x. So 1, 2, 3, 4, 5, 6. Alright, so we got 6 terms. And let me underline them. So 1, 2, 3, 4, 5, 6. So that's a lot. Alright, now again, leading degree, or LD, is the one that has the highest exponent. So this one right here. So if you put it in order, then the first one will have the leading degree. If you did not, then right here is the highest exponent. So my leading degree, or LD, is 10. And then my leading coefficient is the number in front of the variable that has the highest exponent. So in this case, negative 12. So my leading coefficient is negative 12. That is the number in front of the x that has the highest exponent. And then I'm just going to box my final answer. And then that's it. That's all you have to do. So be mindful. If you were asked to put it in order, you're going to start with the highest exponent, going to the smallest. If you were not, then just simply look at the exponent, which one's the highest. That will be your LD, 10. And then your leading coefficient is the number that's in front of the variable that has the highest exponent. So your LC is negative 12. That's all you have to do.